Where's the solution? Now, you know that substitutes are those which are used to what? To replace one another. So what are complements? Complements are those which are used to complement one another. Right? So it's the reverse. These complements are those which must be what? Used together. Complements are those which must be used together. Cross lesson 8 minutes. Means you are very fast. Because Monday class, Thursday, Wednesday, all lesson. Means I speak too fast. So I saw that lesson 8 minutes. That's why I speak slowly. Otherwise, I'm not too fast. First, what do we understand about complements? We have learned before. They must be used together. For example, what is a perfect complement? Boyfriend, girlfriend are perfect substitute for perfect complement. Will you consider your other half perfect substitute or complement? Perfect complement, well, both must be used together in order to get rid of the. Okay, so as long as the two things are used together, now, if their complements, look at the utility function. It's not a straight line, it's L-shaped. Why? Why complements the utility function are L-shaped? So let me show you. Now, for example here, the perfect complement that I'm talking about is left shoe and right shoe. Now I'm sure these are perfect complement. Isn't it? If you go shopping center, you never see someone wear two left shoes. Right. You have one left shoe, you must always be complemented with what? One right shoe. Have you ever seen someone wear two left shoes outside? Very hard to find. That's late lecture. Okay? So they must be used together in fixed proportion. 1 to 1. So if you have one left shoe and one right shoe, now that will give you a utility of how much? One left shoe, one right shoe. So that will give you a utility equal to U naught. Now do you think that if I have one left shoe, y equal 1, y equal 1. By increasing my right shoe to 2, so my utility rise. So here, one left shoe, two right shoe. So my utility increase. No, still use it. You should know why, right? If I have one left shoe, what for I'm going to have two right shoes? Right. The other extra right shoe where am I going to wear? That's assuming you're two-legged. So any two-legged person will find this extra right shoe useless unless you have 3 legs. Then you can wear it on the 3rd leg. Right. So if not, assuming that all of us have 2 legs, therefore this is redundant. So therefore when your y equal 1, if your x equal 2, the utility will increase, still use 0. When y equal 1, if x equal 3, here, will the utility be higher? No, still use 0. Understand? That's why horizontal. Because they must be used together. Having one left shoe, no matter how many right shoe I have, it's no use. One will do. Right? So that's why the utility is constant and useful. Now, in the same manner, why this is this way? X equal 1. Now, when the x is equal to 1, if I increase my left shoe to 1, that will be fine. 1 to 1 will give me 0. Now, when my x equal 1, do you think if I increase my y to 2, when my utility rise, still use 0? Right, y equal to x equal 1. Because, like I said before, if you only have one right shoe, one left shoe, having more than one left shoe, what are they doing? Doing nothing, you have to carry in your hand. Right, luckily your utility don't drop. Okay, so we assume you have a lot of hand. So utility still use 0, that's why still a straight line. So you understand why now, the back component, the utility curve is L-shaped. So it's this way. Now, if the utility curve is L-shaped, that means if you have 2 left shoe, 2 right shoe is all you need, right? To give you the utility. Anything more than 2 right shoe will be redundant again. So L-shaped. Now, then what is the mathematical equation for this L-shaped curve? Mathematics. For this straight line, you know the math is this, right? If it's L-shaped, the mathematics will be this. Simple or perfect complement. That means in mathematics. So the thing is, what do you mean by this? Now the utility comes from 2 things. Right. So the 2 things is x and y. These are 2 things. So what do you mean by the utility of these 2 things is what? What does u of x mean? What does u of x mean? It means the utility from x is this of x. Okay. What does u of y means? U of y means what? It means y means the utility from y means y units of this. Simple. So the 2 things is called x and y. U of x is the x means the utility from what? From x units of x units of x. Y means the utility from y means y units of y. T means what? The utility from t units of t. Okay. And the utility is always the lower of the 2. Now why lower? Now that's because you see, for instance, if this person has 2 left shoe and 3 right shoe. Now suppose every shoe give you 1 unit of utility, right? I mean, the utility should be based on 2 left shoe or 3 right shoe. 1 shoe give you 1 unit of utility, 2 left shoe give you 2 units of utility, 3 right shoe give you 3 units of utility, right? So therefore the utility should be based on which one? 2 U-case or 3 U-case? 2 or 3. And the answer is based on the minimum of the 2. The lower of the 2, so it's 2. Now the reason why is very simple. If I have 2 left shoe, 2 right shoe, it's all I need, right? Perfect complement. What's the use of having 1 extra right shoe? Where? Where on the hand? And I'll be around the hand will walk. Round. So, of course, the utility has to be based on the lower of the 2. Because those extra will be useless. It cannot give you utility. Okay? So it's always the lower of the 2. So, if your budget line is here, you have a person consume. maximize utility, here is the diagonal solution. Understand? Now, for example, let's look at here. John utility function is this. So let's look at the answer first. I want you to think. Now, John utility function is this. He derived utility from what? These two things. Okay? So the thing is not called x and y. It's called gene and hormone. Now, in order to, you must have 1 ounce of gene, 2 ounces of hormone to make a perfect martini. Now, each martini give him 1 unit of utility. Write down John's utility function. How do you write? First, these two things, G and V, they are what? Perfect substitute, perfect complement, or imperfect substitute. G and V. You have to classify them because of mathematics depends on how you classify them. Are they perfect substitutes? No. They must be used together. Fixed ratio. Is it 1 to 1? No, 1 to 2. Okay, as long as they are used together in a fixed proportion. Perfect complement. Okay? So what does that mean? Write down John's utility function. Now, his utility comes from two things. G and 1. E. You know that. What do we know? We know that you need this plus this. We'll get what? 1 martini. And this will give us what? 1 unit of utility. Okay? So that's 1. Okay, so he derived utility from G and V. These two things. Is required to produce 1 of this and 1 martini give you 1 utility. Can you give me his utility function? First, in order to write his utility function, you need to be able to understand what this means. U of G is what? Now you know that they are perfect complement, right? They must be used together in fixed proportion. So the only thing you know therefore is this word. Interpretation. U of G is what? The utility from G units of V. U of V, the utility from V units of V. Right, so the fastest way therefore is to look at the answer. The interpretation is found. Okay? The utility from G means G units of V. So and so forth. I think now you understand why the answer is this. Can you figure out now why the answer is this? This is this utility function. Figure out. Okay, so very straightforward, right? It's the lower of the two utility. So the utility from G miss, from G units of G. Now we know one G give one martini and get one UTL, right? Therefore G units of G give how many UTLs? One G give one UTLs, G units of G give how much? G times 1 is called G UTLs. Now what we know we need 2V to make what? One martini, therefore one UTS, right? Now 2 ounces of V to get one UTS. One V give how many UTS? One V give how much? Half. 1 units of V give half UTS. V units of V give how much? 1 units of V give half UTS. V units of V give V times half. V times half is called V over 2. That's all. So therefore the utility is based on the lower of these two. Simple? So therefore perfect complement. Now, for instance, find for me the answer for if you have G equal 1 and V equal 100. What's the utility? What's the utility equal to? G is how much? 1. V is how much? 100. Right? The utility should be 1 or 50. Okay? Simple. Lower of these two utility. The reason is very simple. If I only have 1 G, I have 100 V, how many martini can I make? 1 only. You only need 2 V. Right? So, the other 98 V, what you do? You can throw away. The most you can 1 martini and therefore 1 units of utility. Okay? You don't throw away. If you use it all on 1 G, will you get martini? I don't know what you get, but maybe it's not martini, martini. Right, overdose. Right, overdose. So it's always based on the lower. Okay? Because they must be used together. So the lower one set a binding constraint on how much you can produce. Okay? Okay, so let's look at imperfect substitute. For the case of imperfect substitute, so this is something that you are very familiar with y. So this is something that you really want to know. Yeah. Now, when the two roots are not perfect substitute, then your utility curve is this. Okay, you see this shape. So this is our standard analysis for two things being imperfect substitute. So in mathematics, what's the equation of this line? In mathematics, the equation of this line is what? Yeah. Right. So the utility comes from these two things, x and y. And so therefore, the map for the convex shape will be this. So it's an exponential multiplicative function. Right. So with this, you plot, you get a convex utility. We call this the Cobb-Douglas utility function. So it's just simply a multiplicative function. And so of course, your mathematical equation is this, you're going to use this line. Very probably. So the equation will be this. That's all. Now, so what's the equation of the budget line? What's the equation of this budget line? That's what we said before. Is the slope of the budget line, dx over dy. Now, we also have done before very quickly. The consumer will choose which point on the budget line? Tangent point. Why? Because that will give the highest utility. Okay. You understand that right? You learned before, right? Why not other point? In other words, why not this point? Why not here? I'm sure you can choose here, right? Why not choose here? Simple. If you choose here, the utility is higher or lower? Lower because at this point, you touch this utility curve. Is it lower than U0? Sure, right. So nothing will be under A. So that's all we know. Now, in intro econs, what we do is we just use the graph and show here. So we said we always choose this bundle. But in ME, you need to calculate this bundle. It means for sure you will buy x naught units of x, and you will buy y naught units of y. Why? Because that will give him the highest utility. But in ME, you are required to find this bundle. How to find x naught and y? How to find x naught and y? Now first, this is the bundle at here, right? That means if we wish to find x naught and y naught, you have to find the mathematics at this point. Now at this point, first, the value are the same. Also at this point, the curve, the two curves have the same mark. They are tangent to each other, that means they have the same mark. Slope. So therefore, this point, if you write mathematics, means the slope of the budget line, which is px over py, is equal to what? The slope of the utility curve. So what's the slope of the utility curve equal to? You learned before. The utility comes from where? From x and from y, right? So therefore the slope of the utility curve is equal to MUX over MUY. Okay, comes from these two things. Any question? So this is the mathematical expression for this point. So if you wish to find x naught and y naught, you solve this equation. That's all. Clear? Any question? No. But for Cobb-Douglas equation, it's easier than this. Because for Cobb-Douglas utility function, you can find the optimal x and y even much faster. Why? Because, you see, the optimal x is some fraction of what? Here. M over px is the maximum quantity of y you can buy. M over py is the maximum quantity of y you can buy. So the optimal x is some fraction of the optimal, the maximum x you can buy. The optimal y is some fraction of the maximum y you can buy. What is that fraction? Now, if it's Cobb-Douglas, it's very easy to find the fraction. If it's a Cobb-Douglas multiplicative function, you can easily find the fraction from the exponent, from here and here. For example, the optimal demand for x naught is equal to some fraction of the maximum x you can buy. This is the maximum x you can buy. Maximum quantity of x you can buy. The fraction is determined by the exponent. For good x is c divided by the sum of the exponent, c plus d. That's how you find x naught, very fast. For good y, it will be d divided by the sum of the exponent times the maximum quantity of y you can buy. Is this fraction. Simple? That's all it is. Clear? So for Cobb-Douglas, it's very simple. You can find the optimal demand for x and y just in this manner. Okay? Any questions? Now that also means what? That also means if you take this equation and you bring this ball to the left hand side, what do you get? You bring the blue color ball to the left hand side, what do you get? Okay, so this one what I found for you is that this is the optimal x naught graph. This is the optimal one. For Cobb-Douglas, you can just do this shortcut. Right, because it's some fraction of the maximum x and y you can buy. The fraction is determined by that exponent. Now from here, if you bring this ball to the left hand side, you'll get this equation. Bring this here, you get here. Can you see why? You see? This ball, if you bring to this side, it becomes this. This ball, you bring to over this side, you get this. Okay, I want to do some interpretation now. For Cobb-Douglas consumer, you notice the amount of money that they spend on good X. For Cobb-Douglas consumer, the total amount of money that they spend on good X in relation to their income is always a constant. You see or not? The Cobb-Douglas consumer always spend a fixed fraction of their income on each goods. What's the fraction? Yeah, all these are constant. His spending on X in relation to his income is a fixed fraction, let's say 1/4. His spending on Y Py times y as a fraction of his income is, let's say, 3/4. So a Cobb-Douglas consumer always spend a fixed fraction of his income on both bills. So that means what? If this is a constant, if the fraction is a constant, which means if the price of X rise, by right this must go up. It cannot go up in mathematics because this is a constant. So therefore, if this go up, since this cannot go up, that means this must come down by the same amount. Otherwise, impossible for this to be a constant. Now, given in mathematics is a constant, so when the price of X rise, we know that the quantity demanded for X must fall by the same proportion. You agree? Why fall? Because the law of demand. When something becomes more expensive, you buy less. How much less? I know the fall must fully offset the rise here. It has to be, because this thing cannot adjust. Okay? Any question? That's why you see a Cobb-Douglas consumer always spend a fixed fraction of his income on these goods. And this fraction does not change with prices and income. It's always fixed, which means that if the price of X rise by 10%, his total spending on X rise or fall. And the price of X rise by 10%, his total spending on X rise or fall. No change. Because X will fall by the same proportion. Understand? It has to, because this is a constant. It cannot adjust. So therefore the adjustment is true for the B. Okay? Okay, so now we'll look at let's look at group 1. So let's look at group 1. Group 1. This one is very long.